Hello, digital logic people. Returning to the example. So I was going to do the equation, then simulate, and then RTL and simulate. But if you've made it this far, that means you saw the last one. For some reason, my internet got flaky while it was working. Um, I have now fixed it the second I stopped the recording instantly. EDA Playground started working again. So I'm just guessing the upload of the video was killing my internet connection. So we um now it's back to running. Hopefully it'll run now that I've got it going. I'm gonna do the run before switching back and forth because I want you to actually be able to see it. So I have I moved the wires back up. Actually, when the second it stopped and I refreshed, I had to refresh the whole and log back into EDA Playground, but it started working great all on its own. The wires moved back to up here, so I don't know what had happened. It just got screwbally. So anyway, this was our equation version. It was called Model 1 equation. I do have it saved in here. So you're going to be running this section, or I'll be running this when I click run. If yours does not have that, then just modify that and save it in your own session. And then we'll click run here. Hello. Oh, come on, don't do that. All right, we click run. Oh, gotta love when you're doing everything on the internet. Um, And so we run, we can see it looks pretty much the same. I'm going to click on this and move it up because it's easier to do the comparison. Uh, we went through the gate level one at nauseating, even kind of boring for me details. So just remember at these points, we only do the updates from right next state to state at the positive edge. So one becomes one becomes one, so on and so forth, um, down to here, next positive edge. 2 becomes 2, 0 becomes 0. So that's all you have to do for these. 1 becomes 1. So realize if it's not on a positive edge, right, um, doesn't change. So 2 becomes 2, but that's why this 3, there's 3 goes up to a negative edge. So 3 cannot come down because there's no positive edge. By the time the next positive edge hits, right, the value that's here is a 0. So 0 becomes 0. Only positive edge. You can check all the way down. It exactly does that, right? Only at the positive edge, next state becomes state. Um, and then you can check in between. Any update in the negative state is basically current state plus the input value. You can look at the table or the graph, and that will generate what is the value of your next state. And you can verify that that is indeed true. Um, we can take a look at any of these ones, like right here. We can just say, great, what is the value? The state is 1, and the input is 0. So if I flip over here, right, the state is 1, the input is 0. It should go to 2. So state is 1, input is 0, the next state is 2, exactly as it says. So you can verify all the positions down the line. All these changes happen because either the state changes or the input changes. And that's why there's so many of these. But not all of these are red at because they're not at a positive edge. So therefore, the state itself is a subset of all these changes. So anyway, that shows you that that does indeed work. You can verify each one on your own. Um, I want to make sure I get through all these before my internet decides to go screwbally again. So the equation works. We talked about the RTL code, which was nice and easy. It's very easy to read. Basically, a nice simple thing right off the table. And then we can just change this to RTL and we'll use this model. Once I change that, I have to save it. Please save. Okay. And then we run. So now we're running the RTL code. Um, things work. And like I said, it um, copies this up here. And remember what I said, the without any seed in there, it picks a particular thing, but then it follows the same exact pattern. So it's random in that I'm not specifying a value, but um, it's a fixed seed number. I think it actually picks zero as its seed, which is kind of boring. But um, each one of these are getting the exact same sequence. It's just not a sequence that I picked. I let random pick it, but random will keep picking the same thing um, because I didn't give it a different seed each time. The seed determines what particular sequence. Okay, so in any case, you can notice it does the exact same thing. Positive edge, two becomes two. You remember all these one becomes ones coming down, and you can just keep looking at, right? Zero becomes zero, one becomes one, two becomes two, zero becomes zero, one becomes one, blah, blah, blah. Right? You check it all the way down. It does that update. And you can do the next state logic check again, right? State one gets an input of zero. If you remember from just a few seconds ago, that means it should go to a two. So you can check and make sure that, state plus input does indeed specify the correct next state, and then that positive edge, next state goes to state. Um, Again, verifying that shows that indeed the RTL one also works. So all three of these models work great. I can use the same basic test bench, only modifying the name of the data type to flip between them. And we've shown how we can do both waveforms and random values being input in to test them. So this gives us a nice clean model. It's still a simple test bench, but we're getting a little bit fancier, a little things that you would actually do at the typical um, kind of first interny level of work in industry. So you actually have building up some good Verilog skills um, to be able to do this testing. So anyway, I'm going to stop this video. Um, it gives you lots of good stuff to do. Hopefully it makes a lot of sense. You can play around with your code and change it to different models. You're welcome to do a lot of the things on here. If you have problems doing simulations, the only thing you wouldn't be able to do lab-wise in here is you just can't compile the code for programming, but you can actually upload or download this code to test it and make simulations if you're having fun or trouble with Xilinx. Have a good day. Bye.